Now I'd like to talk a bit more about the G1 garbage collector, so I've switched my application so that it's going to run using Java 11 now, and therefore it's going to use the G1 garbage collector. Let's remove the other command line arguments before we run the application. So I'm just going to leave the heap size at 20 megabyte. I don't want to have any other runtime arguments just at the moment, and we'll run this and have a look at it in JVisual VM. So we'll connect once again to the running application, we'll go to the Visual GC tab, and hopefully you'll see straight away this looks very different. First of all, you might notice that S0 and S1 are different sizes. S0 is empty and S1 is, well, it looks to be pretty much full. Now Eden is growing quite slowly, so I think I'm going to leave this to run for a little while and just see what happens as the size of Eden grows. I'll let that run off camera and I'm going to press resume in a couple of minutes. Okay, so that has been running for a little while now, and as you can see we had a garbage collection, Eden emptied out, and well, there wasn't a swap between S0 and S1. S0 is still empty, S1 looks to be pretty much full, although some objects did get moved into the old generation. So this is definitely acting in a different way to what we've seen before. Now I'm not going to be able to go into a huge amount of detail about all of this, but I'll try and give you a flavour of how the G1 garbage collector works. The starting idea is actually quite different to what we've been talking about up until now. The heap is split into regions, and by default there's actually 2048 of them. Initially, some of these regions are allocated to the different parts of the heap. So some will be allocated to Eden, to S0, to S1, or to the old generation. Not all of the regions do need to be allocated initially. When Java decides that a garbage collection is needed in the young generation, it looks at those regions allocated to the young generation. It does the garbage collection process, and then it can reallocate the number of regions allocated to each part of the young generation to give it what it thinks will be optimal performance. So each time a young generation garbage collection happens, the different parts of the heap could be changed. For example, the garbage collector might decide some of the regions that have been previously allocated to the survivor spaces should now be allocated to the Eden space, and it could decide to add some of the unallocated regions, for example, to the Eden space. So that happens every time a minor collection is needed. When a full garbage collection takes place, what will happen is that the garbage collector will work out for each region in the old generation which regions are mostly garbage, and it will collect the garbage from those regions first. Actually, that's why it's called G1, the garbage first collector. If a region contains only unreferenced objects, that's a completely garbage region. It can be fully cleared and made available. And in fact, the G1 garbage collector doesn't actually therefore need to look at the entirety of the old generation. If it can clear a few regions, that might be enough so that a real full garbage collection on the entire old generation isn't actually necessary. It can still do a full garbage collection on the entire old generation if it's really needed, but hopefully that will be a rare occurrence. So the idea is that the performance of the G1 garbage collector should generally be better than the other types of garbage collector that we've been looking at, because when it needs to do a major collection, it can often do just part of a major collection to free up enough memory, and it has the ability to resize and reallocate different areas of the heap to different parts of the young and the old generation, again to maximize performance.